Okay, my name's Patrycja Wegrzynowicz, and today I'm going to tell you about some features of JPA related to lazy and eager loading strategies. First, briefly about myself. I've been doing professional software development for over 15 years. I've always been close to code, and I still am an active coder. And I must say, I love it. Oops, sorry. Okay. Wait a moment. Still technical problems after a start. Okay. It should be fine now. Okay. No. Okay, it should be fine now. I hope. Most recently, I founded a company. It's Yonita. At Yonita, we aim to bridge the gap between the industry and academia. And we are working on automated tools to detect and refactor software defects like security vulnerabilities, like performance issues, like database anti-patterns. So basically, my daily job is to find out how many ways you can shoot yourself in your foot. Oops. The outline. We will answer three main questions. Why, what, and how. Why? Why at all there are so many problems with our JPA providers? What are the use cases and what are the corner cases? What are the hints on loading strategies? And how we can solve or at least address somehow some of those issues with JPA 2.1. Databases. Databases aren't sexy. I would like to share a story with you. 20 years ago, I was a student of computer science, and I was taking an exam in foreign language. And my teacher asked me a question about my future. That was a very puzzling question. Nevertheless, I answered, and my answer was that I don't know who I want to be in the future, but I perfectly know who I don't want to be. I don't want to be a database engineer. And now, 20 years later, standing in front of you and talking about databases, it's kind of irony, I guess. Anyway, we are Java developers. We have to go there to our databases and get back again, and as quickly as we can. So it seems that databases are like motto of Java developers, and I would like to make your journey there more pleasant. However, there are a lot of unpleasant surprises on our way there. And first, we start with a small puzzle with Hibernate. Hibernate is one of JPA providers, I guess most popular one. Who uses Hibernate? Yeah, raise your hands, please. Yes. And who uses any other JPA provider? Oh, only 5 or 4, something like that. Yes, so Hibernate crushingly wins. Okay, Hydra. Hydra is that mythical creature who is supposed to regrow 3 heads in place of 1 head cut off. So we want to have a rich business model. We want to put this constraint into our code. That's why our Hydra has rich getter and head setters, and that's why we provide get heads, which returns unmodifiable lists of heads. The mapping is pretty simple. We rely on defaults for JPA. We use simple entity annotation, and we use one-to-many with cascade option all for Hydra's heads. Then in one transaction, we create and persist a single Hydra object with 3 heads. In the second transaction, with completely new entity manager and new transaction, we just retrieve the single previously stored Hydra. So we execute find on entity manager. And the question to you, how many queries Hibernate issues in the second transaction? It seems that the case is pretty obvious, right? We have only one Hydra to retrieve. For sure, we reissue select to retrieve the single Hydra object. Then it depends on lazy or eager loading. We can retrieve in the second query the heads of Hydra. By default, one-to-many has lazy fetching. So it should be only one select. Okay, so the question to you, how many thinks that it's one select, the option A? Please raise your hand. No one. Yes, that would be too simple, right? What about B, 2 selects? How many? Please raise your hands. No one? What about C? Yes, there are a few of you. What about D? 2 selects, 1 delete, and 3 inserts. Anyone? Yeah, that would be pretty stupid, right? Because there is no modification here. And E, none of the above. Yeah, some of you know that you can expect unexpected from Hibernate, so maybe something different. Okay, the right answer is D. No one chose this answer. Why? Because it's so unexpected. Because we have read-only operations. We don't touch the object at all, right? So what happened here? During commit, Hibernate checks whether the collection property is dirty, so whether it has been changed or not. And it checks it by comparing Java identities, object references. So let's take another look. And you see here that during find, Hibernate executes only one select, just to select one Hydra. And then during commit, it then issues one select, additional select, 1 delete for heads, and 3 inserts for heads. Why? Because here we have that getter which returns unmodifiable collection. It's a wrapper around the original collection which was injected by Hibernate. Hibernate injected its own proxy just to lazy load this collection. And when we, during commit, Hibernate checks whether the identity of the Java object has changed, not the elements in the list, in the collection. So the identities are obviously different because here we use the mappings on the property level, not the field level. So it hibernates, has the stored collection, then invokes get heads, and obviously these identities are different. So it thinks that the collection has changed and it needs to recreate it. So lessons learned here, expect unexpected. That's what you've already should know about Hibernate. Another lesson, preferred field access mappings, and operate on collection objects returned by Hibernate, because even in such a case when you simply get heads and set heads, the same heads, Hibernate will recreate the collection even if we set up the field access mappings as our preferred model of mappings. So don't change collection references unless you know what you're doing. How other providers behave in this case? Actually, they are smarter than Hibernate, because Eclipselink and Data Nucleus only issue one select, so that's much better. Unfortunately, OpenJPA in that case simply failed. So at least Hibernate works, that's good. You can find more about comparison of JPA providers in my talk titled Performance Comparison of JPA Providers. Okay, so what we've learned here. A lot of depends on JPA provider. JPA is only a spec. It says what to implement and it doesn't say how to implement that. And there are many differences between various providers. So if you want to tune your application, you need to tune in a concrete environment. And I mean here JPA provider as well as a concrete database, because different databases behave differently as well. And now, I was saying that not to bash JPA or providers. I do love JPA. It takes off the burden of writing boilerplate. That's fantastic. But as in every relationships, we have our ups and downs. And after such cases as Hydra puzzles, I'm very puzzled, annoyed, and often ends like that. Anyone here shares my feeling? Raise your hands, please. Because that's horrendous. Okay, so let's move to more typical use cases. In most of our application, we have like listing of objects, entities, and reporting features. So we list objects for our users. We need to report some aggregated statistics about what's going on under the hood and what's going on with our objects and entities. And what are the anti-patterns here? That we apply the same model in different contexts. The same entity model. Direct usage of an object-oriented domain model for different contexts may lead to very poor performance. Why? Because usually we have too much data loaded, not the data we need loaded, and we usually have very heavy processing on the Java side instead of using database engine. And the example, we have a very simple model here, and we only focus here on an employee and address relationship. So each employee has one address. And the mapping is obvious. We only use one-to-one with join column. And another important property is salary. So it's by default mapped as a numeric field to a database. And now we have a report when we want to retrieve the sums of salaries by country for our employees. And maybe that's not the smartest approach, but I've seen such an approach in real-world code. So that's a simple select to retrieve all employees, and then we count the partial sums by country in Java code. That might be the simplest solution from the point of Java developer. What's wrong here? The problem here is that we end up with n+1 selects. So we have one select to retrieve employees and then n selects to retrieve n addresses of the previously selected employees. So in terms of database, we have a lot of queries. We can address this issue by using join fetch. So in JPQL, we know that we will need the address. So we want to retrieve this in one query. That's why we are using join fetch. And the rest of the code is the same. The third approach is to use sort of a projection. So we only retrieve the data we need. So we need only a salary and country. And then again we evaluate the sums on the Java side. The fourth approach is to use JPQL aggregation function. So we just it's just translated into SQL with aggregated sum function. So we don't need to calculate anything on the Java side. And the fifth approach is to use native query, so just plain SQL, and basically very similar, I guess, the query which is generated by any JPA provider. What about the performance of those 5 approaches? Here you can see. For my benchmark, I've used Eclipselink and 100,000 employees. That's not very much. But you can see that the first approach is 5 times slower than the second one. So this n+1 queries almost kill our application. Select join fetch is pretty fast, but still it's like 10 times slower than using projection. Projection was only to retrieve the data we really need. And then we calculated the partial sums on the Java side. So Java as a calculation engine is not a problem. That the problem is in retrieving too much data. And obviously, aggregation in JPQL or SQL are the fastest, and there are not much difference between the two. And please take a note that aggregations are not that much faster than projection with calculation on the Java side. So basically our main problem is that we fetched too much data. How can we address that? So first, on the previous slides, you've seen a very simple projection with JPQL. The problem was that we retrieved the list of arrays of objects. So that's not very convenient, and it might be a problem to cast the object, to know what it's inside the array, and so on. So we are losing type checking. The better approach is to project our retrieved data directly into a value object. So you can do that with JPQL by using employee VO constructor explicitly. Or you can use in JPA 2.1, you can use construct result mapping for SQL. Because in JPA 2.0, there was no way to map the result of array of objects into value object directly. You needed some boilerplate code. So that might be a good solution approach to your problems. And here we have, with projections, we have much faster performance. Why? First of all, we retrieve only data we need. That's the first gain, obvious gain. The second thing is that we don't use managed objects. Managed objects, managed entities, they are stored in Entity Manager. Under the hood, it might be Hibernate session, and they live through entire transaction, through entire session. And they need to be synchronized in the end of the transaction. That's what was the dirty checking about, that we had a managed object. Our Hydra was a managed object. And Hibernate or any other JPA provider must check the dirtiness of objects. So using projection and direct value objects, we allow Hibernate to perform what it does fast, and we take off the burden of dirty checking and basically management of entities. In case of JPA 2.0, only JPQL queries can produce value objects directly. In JPA 2.1, you can use native queries as well to produce value objects directly. In case of use cases, think about reporting, statistics, history, basically all read-only data. Your use cases for graphic user interface that are purely read-only. And in that cases, consider usage of projections and value objects for that directly. Okay, so let's move to loading strategies, and when we want to apply eager loading strategy for sure. If we know what we want, we know the range of required data in our future execution path, so we know that we will access the data, then we want to load it eagerly, because usually it will be faster. If we want a relatively small entity, there is no need to divide it into tiny pieces, right? Because it will slow down the performance, like that n+1 queries. Each single query was pretty fast, but in total it made like a huge performance overhead. Also consider network latency to the database, because it's not only about executing query on the database engine, it's about network latency. Usually our database resides on a different machine, right? So we need to connect to that different machine and send packets there and get back again. So lower number of front bits to the database in case of many small queries. When we want to use lazy loading strategy, for sure. If we don't exactly know what we want, so there are different scenarios and different execution paths, then we should apply Scarlett O'Hara's motto, and I will think about that tomorrow, and load only required data. If we want to load, obviously we don't want to run into like out of a memory exception with low memory and with low memory available and high memory consumption. Obviously we can get into some performance troubles. So then we should apply divide and conquer strategy and load what's needed in the first place and then load the next segments. In case of large objects, I'm not sure whether you know that you can set fetch type on a property as well. You can use it for blobs, slobs, or formulas. But you need to keep in mind bytecode instrumentation because otherwise it will not work and it will fail silently. So it will be ignored silently. So it might be worthwhile considering usage of fetching time on basic properties for large single objects or formulas which take a long time to execute. But first, think about large objects, whether it's the right place to store them in a database. I must admit that I made that mistake in the past. It was a long time ago, like 15 years ago. We were designing a system for archiving. And we wanted to make sure that our objects are documents are properly backed, and we wanted to make use of database properties for sharding or for replication and so on. And we decided to store our documents in a database column. That was a mistake. Don't make it. Because very soon, with thousands of objects, the database went into such a heavy load that it was mostly unusable. So consider, do you really need large objects in your data model stored in a database? And if you say so, then consider once again. And if you say so, okay, do it, but be careful. In case of large collection, the obvious solution is divide and conquer. Definitely lazy. You don't want really large collection in your memory. And here JPA does not have any generic solution. You need to go to your JPA provider like Hibernate or Eclipselink. They have specific configuration parameter for batching. So you can, for example, in Hibernate use batch size annotation and say in how many elements in one query will be loaded. Otherwise, it will be like loading one by one. So that's a problem. Okay, I have another puzzle for you. Plant a tree. Again, that's a very simple model. We have a forest with trees. We have one too many on our collection of trees. And we have a tree entity with back reference to a forest, which it belongs to. So that's a common pattern and described on many web pages, many manuals and tutorials to keep your model in sync. When you plant a tree, you need to, when you create a new tree, you need to add it to that tree forest as well. But that's in case of tree with many to one mapping. Our example here is much simpler. We have one-to-many as the owning side. So when we want to plant a new tree, we just add a tree to a collection, and that's it. So again, we have a new entity manager and new transaction that creates and persists a forest with 10,000 trees. We have the second transaction in which we create a new tree, we persist it, so for sure there is one insert for a single tree. Then we find a forest. Then we have for sure one select to find a forest. And then we plant the previously persisted tree in our newly retrieved forest. So for sure there is one more insert or update to make a connection between a tree and a forest. So it would be like, for me, one select and two inserts. That would be optimal. And obviously that can't be the right answer, yeah, because that wouldn't be a puzzle. So I guess no one will choose A, right? You're smart audience. What about B? Two selects, two inserts. Yeah, that's too small, I guess. What about C? Who goes for C? I see a few hands raised. Yeah, one more. Okay, what about D? Like 7 or 8. And E, even more. Yeah, expect unexpected. Oh, in that case, it's not that bad. It's only C. Two selects, one delete, and 10,000 plus two inserts. Why? Why at all? Because 10,000 inserts means that we like recreating the collection, the entire collection. Why? We planted just one more tree. The answer is that the combination of one-to-many and collection enables in Hibernate a bug semantic. That's why collection is recreated. Can we change it? Like to another Java type, if we used more ordered forests, like an ORCAD with list, does it change anything? No, unfortunately no, because to keep track of a position in the list, Hibernate needs a direct hint. We need to use order column or index column annotation for the list semantic for Hibernate. That's pretty tricky, and many people does not know that. What if we use set here? There is also a problem, because to ensure the set semantic on the Java side, which means that we can't have double elements, multiple elements of the same key in our set, the same hash code in our set. So it means that Hibernate needs to load the entire collection into memory. So the effect is that our memory gets slower, our application gets slower. And we can have run into transaction and locking schema problems, because in case if we have optimistic locking, versioning here, when we lock the forest, we lock all trees as well. So in case of transactions, any other transaction that touches a forest, plants a single tree, we have like entire forest and all trees locked. So that's another problem. So maybe we should use another form of a mapping and use many-to-one in a tree as the owning side, and one-to-many being only the inverse side of a relationship. That would be very good, and it can provide like an optimal execution plan for our database. However, in case of one-to-many set, Java type is not appropriate as well, but because still Java needs to ensure set semantic for the Java collections. Then we need to, in case of a typical implementation, when we have a back reference, you want to synchronize our model in the memory, we need to add a tree to the forest while creating a new tree, and then implicitly the entire trees will be again loaded into memory. How to avoid that? In case of one-to-many used as an inverse side of relationships, it's better to use lists or arrays or collection. So in that case, if you use Java type list or collection, Hibernate will not load the entire collection into memory. That would be optimal. How other providers behave in that case? They are, again, smarter than Hibernate. Eclipselink, 2 selects, 2 inserts, OpenJPA, 3 selects, 1 update, 2 inserts, and Data Nucleus, 3 select, the same. So you've just learned again how important is the JPA provider you actually use in production. In case of loading strategies, usually it's my favorite answer, it depends. It depends on the context, because that's the answer which suits almost every technical situation and problem. So in case of it depends, it means that your scenario is dynamic depending on an execution path and its parameters. And that problem was in JPA 2.0, because you didn't have any way to configure it in runtime. So either you could use fetch queries, so you could load too many elements into memory. You could use provider-specific extension. You could use different mappings for different cases. So basically, that means more work for us developers. Here, JPA 2.1 comes in handy. We can use entity graphs in JPA 2.1. Basically, entity graph is a template that captures the paths and boundaries for an operation or query. It's like a fetch plan. It can be defined by annotations or created programmatically. By annotations, you can use named entity graph, subgraph, and attribute node, similar methods from interfaces of entity graph, entity subgraph, and attribute node. And what does it mean usage of entity graphs in a query or find? Basically, it means that you are overriding the default fetch configuration. So, default fetch graph is like transitive closure of all its attributes specified or defaulted as eager, right? And in case of JavaX persistence fetch graph parameter, you specify which attributes are eager and all the others are lazy. So basically you specify how the JPA provider should fetch your domain model. And in case of load graph, you specify the, again, eager attributes, by all others are loaded as specified by annotations on fields or as defaulted. What are the advantages? First of all, better hints to JPA providers. Hibernate can now generate much smarter queries. For example, instead of one n+1 problem, we have one round trip to a database. We can dynamically modify our fetch plan, so think about different contexts, because usually for different page views for our user, we need different subsets of our data, right? So there is no single optimal solution. We need to change our fetching strategy based on this scenario, on the data we need. So that's where we can use projections and value objects or entity graphs. So unfortunately, I need to disappoint you. There is no silver bullet. Even though JPA 2.1 is pretty handy and offers a lot of feature, still we need to learn how to use it wisely. In case of fetching strategies, we need to focus on our main use cases, which usually means listing and reporting. By listing, I mean also displaying of the objects. In case of JPA, we have two solutions. We can use projections for JPA 2.0 and 2.1. That's very useful because we don't use manage objects, which takes a lot of burden from JPA Provider. And we can use entity graphs in JPA 2.1. In case of performance, don't load if you don't need. Don't execute many small queries if you can execute one bigger query. And don't calculate on the Java side if a database can do that. In case of tuning, it's important to tune in your concrete environment. Different databases behave differently, different providers behave differently. So you need to accommodate that and tune for your specific case. We have that continuous integration paradigm. That's very useful. Who uses continuous integration? Yeah, many of you. Also, when I deliver trainings on code quality, how to write good code, I'm talking about continuous refactoring. You need to pay attention to your code and refactor when you see something's wrong. And I would like to introduce a new paradigm, continuous learning. because a full-witted tool is still a fool. We need to educate ourselves on the tools we use, and JPA is one of them. So, thank you. Any questions? If you have any questions, we can talk during break.